Hello viewers, so welcome to my channel. I'm Hasham. So far, 3 problems I have completed on time value of money. In this video, some more problems I'm going to explain on this concept. And remember, this concept is very important for all financial management students. In examination, they will ask you the problems also on time value of money apart from the theory concept. So in the past, I have already uploaded the video on the concept of time value of money. So if you have not watched, I suggest you go to the playlist of my channel, select the subject financial management new, select the video of time value of money. Watch the video, be perfect regarding the concept, then you can understand. Because this time value of money will be considered in taking all financial decisions. Without considering this, no financial decision can be taken. Now, before starting the next problem, that is problem number 4, I expect my viewers to have a printout of the problems and also the table values which I have given in the link under my description. Always keep the problem ready. Take the screenshot of the points which I have written, then I'll explain every point in detail. Come on, see the 4th problem. If you invest 5,000 today at a compound interest of 9%, what will be its future value after 75 years? That means this problem is concerned with compounding. That means we have to find out the future value. After 75 years, how much would be the amount of 5,000 which is deposited today? And the rate of interest is 9%. Already in the previous previous problems, I have given the formula for calculating future value. Future value is equal to present value into 1 plus r to the power of n. So here present value is 5,000 and the rate of interest is 9%, 0.09. So see here, PO, present investment value is 5,000. The rate of interest, compound rate of interest is 9%. N, number of years, after 75 years we have to find out. So FV, future value, that we have to find out. The formula for future value is PO into 1 plus R to the power of N. PO, present value. The present value 5,000. And R, rate of interest is 9%, 0.09. And N, number of years, 75. So it will become 5,000 into 1.09 to the power of 75. But manually on calculator, it will be difficult to calculate 1.09 to the power of 75. So we can make use compound value table. So already I have given that compound value table in the description. You must always keep a print of that compound value. So compound value, since the compound value table has a maximum period of 30 years, the future value expression may be stated as follows. We won't have 75 years future compound value table. So what we'll do, we'll bifurcate that 75 into 3. 30 plus 30 plus 15, 75. Mathematical one rule is there, when bases are same, powers can be added. That will be applied. So instead of writing power 75, we will write power 30. 1.09 to the power of 30 into 1.09 to the power of 30 into 1.09 to the power of 15. Bases are same. So powers can be added, 30 plus 30 plus 15. What you will get? 75. So instead of writing 75, we have taken 30, 30 and 15. Now we have to refer the compound value table. 30 years for 9%. 9% 30 years, we can be able to get the value 13.267. So in the table you can find out 13.267. That is for 30 years. 9% 30 years. Again 13.267. For 15 years. Now again compound value 9% 15 years. 3.642. So 3.642. Multiply all these terms, 5,000 into 13.267 into 13.267 into 3.642. You will get 32 lakh 5,202. So the future value of 5,000 rupees deposited today after 75 years at 9% rate of interest, it comes to 32,05,202. That's it. Next problem. Fifth problem. See the problem number 5. If the interest rate is 12%, what are the doubling period as per rule 72 and rule 69 respectively? So rule 72 and rule 69, that rule is there for doubling the period. Doubling an amount, the period will be received. So how to find out? As per rule 72, the doubling period will be 72 divided by rate of interest. The rate of interest is 12%. So 72 by 12, it comes to 6 years. So according to rule 72, 6 years are required for doubling the period, for doubling the amount. Similarly, as per rule 69, the doubling period will be 0.35 plus 69 divided by rate. The rate is 12%. So simply take 12. Don't take 0.12. Only 12. So 69 by 12, you'll get 0.35 plus 5.75, you'll get 6.1 years. So 6.1 years is the doubling period for rule 69. And 6 years is the doubling period for rule 72. That's it. Next comes problem number 6. A borrower offers 16% nominal rate of interest with quarterly compounding. That means the compounding process will be done every quarter, every 3 months. Year consists of 4 quarters. So 4 times interest is compounded. What is the effective rate of interest? Amount is not given. Simply 16% is the annual rate, but the rate of interest is compounded quarterly, every quarter. So what is the effective rate of interest? The rate of interest with quarterly compounding is 16%, 0.16. Now the effective rate of interest will be obtained by using this formula. 1 plus r by 4. Why we are taking r by 4? Because r 16% is the annual rate, but it is compounded quarterly. So how many quarters are there in 1 year? 4 quarters. So 16 divided 0.16 divided by 4. That means 0.04 is the quarterly rate of interest. The quarterly rate of interest is 0.04 or 4%. Annual 16%. So 16% divided by 4 is 4%. So 1 plus 0.04 to the power of 4. Because in 1 year, 4 times interest is compounded. Interest is calculated 4 times. So 1.04 to the power of 4 minus 1. This will give you the effective rate of interest. So 1.04 to the power of 4, you will get 1.69858 minus 1. So you will get 1.17. If you round off, 1.69858 can be rounded off to 1.17 minus 1 to 0.17, or simply we can say 17% is the effective rate of interest if it is compounded quarterly. If the rate of interest is annual, it will be 16%. If rate of interest is calculated annually, it will be 16%. If rate is compounded quarterly, the effective rate of interest comes to 17%. Sixth problem completed. Now seventh problem. 15 annual payment of 5,000 are made into deposit account that pays 14% per year. What is the future value of this annuity at the end of 15 years? That means 5,000 rupees are deposited every year. First year, second year, third year, like that up to 15 years. Every year 5,000 is deposited. So after 15 years, what will be the future value? The rate of interest is 14%. This is the problem of compounding, because we are going to find out the future value. But annuity means every year 5,000 rupees we are depositing. So annual payment 5,000 and number of years payment is made 15. Then rate of interest 14%. Future value FV is how much? So the future value of this annuity is 5,000 into compound value of annuity. compound value of annuity 14% and 15 years. So we have the annuity, compound value of annuity table. In annuity, we have annuity of 1 rupee and annuity of compound value of 1 rupee and compound value of annuity. So we have to refer to annuity. Why annuity? Because 5,000 not once, 15 times we are depositing. So here on the next page it is given compound value of annuity, right? So how many years? 15 years, 14%. So here it is 14%. Now 15 years. So 15 years it's coming to 43.842. 43.842. So this is the compound value of annuity at 14% for 15 years. Multiply 5,000 into 43.842, 2,19,210. This is the future value of 5,000 rupees every year deposited for a period of 15 years. The rate of interest is 14%. That's it. Now, next problem. Problem number 8. A finance company advertises that it will pay a lump sum of rupees 44,650 at the end of 5 years to investors who deposit annually 6,000 for 5 years. What is the interest rate implicit in this offer? The rate of interest we have to find out. So one company has advertised that we will pay a lump sum of 44,650 if you deposit 6,000 rupees every year at the end of every year for how many years? 5 years. First year end 6,000, second year end 6,000. Like that up to 5 years, if you deposit 6,000, then at the end of 5 years will give you 44,650. So what is the rate of interest implicit in this one? So future value 44,650 after 5 years. And number of years 5. Annual deposit to be made 6,000. Rate of interest R we have to find out. So we will apply the formula for future value of annuity, because every year we are paying. So according to future value formula, annual deposit into compound value of annuity factor at R%. R is the rate of interest we are not given, we have to find out unknown value R% for 5 years is equal to 44,650. Future value is given in the problem. The future value is 44,650. Annual deposit amount is also given 6,000. The only thing, compound value of annuity factor we have to find out. So keep this compound value of annuity factor here and take this annual deposit 6,000 to RHS. So it will become divide. So 44,650 divided by 6,000. I am taking this annual deposit to RHS. So it will become division. So CVAF, compound value of annuity factor at R% for 5 years is equal to 7.442. This is the compound value of annuity, right, at R% for 5 years. Now the next step is we have to refer the annuity table. This is the compound value of annuity table. In this compound value of annuity table, in the line of 5th year, locate this exact value 7.442 or its nearest value. You have to search 5th year line, you have to search in which column we are getting 7.442 or nearest to it. So here if we search annuity factor for 5 years, in the 5th year line, if we search, exactly we are getting 7.442 under 20% column. Under the column of 20%. Corresponding percentage will give the implicit rate. In the present case, the value is exactly 7.442 under column 20%. Hence, the implicit rate of interest is 20%. So what we have done, first we have calculated what is the compound value of annuity. So we got compound value of annuity 7.442. Now locate in the table, compound value of annuity table in the line of year 5. Continuously you search in that line of year 5. You will come to know any value which is nearest to 7.442. But fortunately, exactly 7.442 value is there under the column 20%. So 20% is the rate of interest. That's it. Now see the ninth problem. What is the present value of 10 lakh rupees receivable 60 years from now if the discount rate is 10%? Here we have to find out the present value. Future value is given. What is the future value? 10 lakh. So you are going to get 10 lakh rupees after 60 years. We want what is the present value of that 10 lakh. So amount receivable after 60 years 10 lakh. Discounting rate is 10%. Number of years 60 years. Present value we have to find out. Already we know the present value formula. The present value formula is V divided by 1 plus R to the power of N. V is how much value we are going to receive? 10 lakh at the end of 60 years. So 1 plus R. R is 0.10 to the power of 60. Right? So 10 lakh divided by 1.10 to the power of 60. You should not multiply 60 times 1.10. We can refer the PV table. Present value of 1 rupee at 10% for 60 years. Again, for 60 years we don't have the value. We have the value only up to 30 years. So we make 2 times. Just now I have shown you. Here PV of 10 lakh into PV, present value of 10 lakh into PV factor 10% for 60 years. 60 years we don't have. So we make 2 times. 30 years and 30 years. So 10 lakh into PV factor 10% into 30 years. 10% 30 years into PV factor 10% 30 years. 2 times we multiply. Right? 30 years will become 60 years. Now 10 lakh into, if you refer the PV table, present value table, this is the present value table, 10% 30 years. So 30 years 10% it is 0.057. 0.057. So 0.057 into 0.057. Multiply the 3 terms, you will get 3,249. The present value is only 3,249. Whereas this 3,249 will become 10 lakh rupees after 60 years at 14%, at 10% rate of interest. At 10% discounting rate, it will be 10 lakh after 60 years. Next, problem number 10. What is the present value of the following cash stream if the discount rate is 14%? Year is given 0, 1, 2, 3, 4 and cash flows are given. For 0 year cash flow is 5,000. First year end cash flow is 6,000. Second year end 8,000. Third year 9,000. Fourth year 8,000. This is the stream of cash flows we are getting. 0 year, first year, second year, third year, fourth year. Now the rate of discount is given as 14%. We need what is the present value. So easily by making a table we can find out the present value. In this table, year column cash flows, present value factor 14%, PV of cash flows. So we get PV of cash. How much? 0 year 5,000 cash flow given in the problem. First year 6,000, second year 8,000, third year 9,000, fourth year 8,000. Now we need 14% PV factors. Now you have to refer the present value table. In present value table, 14%. So in the column 14% first year. First of all, remember for 0 year always the present value will be 1. The present value factor for 0 year is always equal to 1. Right? So here for 0 year I have taken 1 as the PV factor. For first year 14%, 877, 0.877, 0.877. Second year it is 0.769. Third year 0.675. Fourth year 0.592. 592. Same thing I have copied. Even if you don't have the table, with a simple calculator you can find out. Simple calculator we can find out. What is the rate of interest here? Discount 14%. So 1 divided by 1.14. 1 divided by 1.14. Simply press is equal to, you will get first year, second year, third year, fourth year. Once is equal to first year, I got it 0.877. 0.877. Second year, if you want, just press is equal to 0.769. Third year, 0.675. Fourth year, 0.592. Same 0.592 I have taken. Whether use simple calculator or you can use the PV table. Now multiply 5,000 into 1 will be 5,000. 6,000 into 0.877, 5262. 8,000 into 0.769, 9,000 into 0.675, 8,000 into 0.592. Total is 27,225. The present value of the stream of cash flows for 0 year, first year, second year, third year, fourth year is 27,225. So far 10 problems I have completed on this topic of time value of money. Inshallah, few more problems are there that will continue in the next video.